Hi guys, welcome back to the second video of set theory of discrete mathematics. In this video we are going to study some set operation, laws of set and how to solve some basic set questions. So let's get started. So here we have some set operation. First is union operator. It is denoted by this U symbol. Let's take an example of union operator. If we have a set A which contain element 1, 2 and 3, and we have another set B which contain element 3 and 4. So A union B is denoted as 1, 2, 3 and 4. Here we don't write 3 two times because it is an unordered collection of distinct element. The next is intersect operator. It is denoted by this symbol here. If we have a set A which contain element 1, 2 and 3, and we have another set B contain element 3 and 4, then A intersection B is denoted as A intersection B equal to 3. In intersect operator we have to write the common element between the set. So you can see here we have 3 in A and 3 in B also. So A intersection B set contain only 3. The next one is difference operator. In difference operator we have to write the element in a set which doesn't contain in the other set. For example, here A minus B contain 1 and 2. Here we first take all the element of the set A which is 1, 2 and 3 and subtract 3 from it because it is in B. So A difference B equal to 1 and 2. Here we have symmetric difference. It is denoted by this symbol. If we have a set A which contain element 1, 2 and 3, and we have a set B contain element 2, 3 and 4, then asymmetric difference B contain the element which belong to A or B but not both. That is A symmetric difference B contain 1 and 4, because you can see 2 and 3 is in both A and B. So asymmetric difference B contain only 1 and 4. Complement of a set can be found as if we have a universal set which contain 1, 2, 3, 4, 5. So, and we also have a set A contain element 1, 2 and 3, then the complement of A contain 4 and 5. All the elements which belong to universal set but not in the set A is in the complement of the set A. Here we are going to discuss some points. If we have a set A which have cardinality M and we have a set B which have cardinality N, so the max cardinality of A union B is cardinality of A plus cardinality of B. This is the case when both the set A and B contain all distinct elements, that is, no one same element of A is in B. The minimum cardinality of A union B is maximum of cardinality of A or B. So here this is the case when A or B has common element in them such that all the element of B is in A or all the element of A is in B. So the maximum cardinality is the cardinality of A or B, which one is maximum. Here we have some laws of set. First is commutative law. In commutative law we have 3 rules, which are A union B equal to B union A. The second one is A intersection B equal to B intersection A. The third one is A symmetric difference B symmetric difference A. The next law is associative law. In associative law we have 2 formulas, which are A union bracket of B union C equal to bracket of A union B union C. The next rule is A intersection B intersection C equal to bracket of A intersection B intersection C. The next is distributive law. In distributive law we have 2 formula, which are A union B intersection C equal to A union B intersection A union C. The next formula is A intersection B union C equal to bracket of A intersection B union of A intersection C. Now we have De Morgan's law. In De Morgan's law we have two rules. If we have complement of A union B complement, then it is equal to A complement intersection B complement. If we have whole complement of A intersection B, then it is equal to A complement union B complement. Now the last law is absorption law. It has two rules. First is A union A intersection B, then it is equal to A. The next rule is if we have A intersection A union B, we have it equal to A. Here we are trying to solve some set question. Our first question is A difference B is not equal to B difference A. We have to prove this. So for proving this, we simply draw a Venn diagram. First we draw a circle and suppose it as A, and then we draw a circle which we suppose as B. So in left hand side we have A difference B. So here we fill the portion which is represented by A difference B. So our required portion is this. Now we take right hand side of the equation which is B difference A. For this we draw a different Venn diagram. Here we have this as A and we suppose this circle as B. Now we shade the part which is required, that is B difference A. So we shade this part. So you can clearly see these two shaded part in the left hand side and right hand side of the question is not equal. So we have proved that A difference B is not equal to B difference A. Our next question is A difference B whole union C is not equal to A minus C union B minus C. For this, first we make a Venn diagram of left hand side. So we draw three circles which is represented as A, B and C. So this is our A, this is B and this is C. First we draw A difference B. So we shade this part. And then we have to union C, so we also shade the part of the C. So here we shade this part. Now we take right hand side of the statement, which is A difference C union B difference C. For this, first we draw three circles, A, B and C. First we shade the region of A difference C, which is denoted by vertical lines. Now we shade the region of B difference C, which is denoted by horizontal lines. Now we have to take union of A difference C and B difference C. So the required region, here we have all the regions shaded by vertical and horizontal line. As you can see from the both Venn diagram, these two are different, so our statement is not equal.
So friends, if you find this video helpful, please like, comment and share this video with your friends. And don't forget to give your feedback and subscribe to my channel. Thank you. See you next time.